Okay, so far we learned about what are anomalies, why do they matter, and we presented 3 reasons behind our interest in anomalies. Now it is about the how to detect them, and after you hunt them, what to do with them, how to treat them. Okay? So detection of anomalies is called anomaly detection, no surprise. Anomaly detection aims to detect abnormal patterns deviating from the rest of the data. 2 simple visual toy examples. I want to give you these 2 examples here. One of them is very intuitive. Let's assume that we have 2 predictors, predictor 1, predictor 2, and this is the feature space. In this feature space, these are our cases. And the cases are not homogeneous. We can see that we have 2 clusters, and then there is something here. So that something here is deviating from the pattern. It's not close to this cluster. It is not close to this cluster. It means that the feature profile, the features of this case is very different from the others. We cannot find any similar case in this data set. So this is an anomaly. This is something that probably you have envisaged earlier. So there is one more important scenario that an anomaly might happen. But before talking about the other example, let's think a little bit about the distribution of the features of the predictors of these points. If you collapse all these points to x-axis, the distribution would be something like this. It would be a hump here, and then a hump here, and then nothing here till this one, because there is 1 point here. But what would happen if we want to project all the points into the y-axis? So let me find a better color. If we collapse all the points onto y-axis, it would be something like this. 1 hump here, and then another hump here, and then, so this one would be somewhere close to this. So it would be 1 hump here and 1 hump here. So we can see that this is anomaly. However, for the feature 2, the predictor 2, the feature 2, it is not an outlier. For feature 1, it is an outlier. Okay? But for feature 2, it is not an outlier. And this is the case that you cannot find anomalies by focusing on outliers. The relation between anomaly and being outlier on features is not very straightforward. In this example, one of the value of this case, of this anomaly, for one of the features, the predictor 2, is actually not an outlier. However, for the first one is outlier. So what would happen if both of them were outlier? So let's assume that we have a feature here. We have a case, here. And in that case, it is an outlier, definitely predictor 2. For predictor 1, it is an outlier. So when all the variables of one case are outliers, then we can be almost certain that it is an anomaly case. However, you should remember that outliers are only defined for numerical values. The anomalies are also considering categorical variables. So the moral of the story is that this is a conclusion that I come back to it again, that having an outlier feature does not translate to being an anomaly. Okay? You might have an anomaly even without having any outlying feature. And this is the second example that I want to present. Okay, the first one was quite intuitive, 1 point far from others. So let me clean up our canvas. Here also, let's say that this is our y-axis, this is our x-axis, this is feature 1, this is feature 2, and the points, let's assume that they have been located on a circle-like pattern. And then there is this point, this case here in the middle. Now let's do it. Let's collapse all the values, all these cases, to feature 1 and feature 2 to see the distribution of the variables. So if we do it, we can see that for feature 1, the distribution is something like this. It is from here to here, and more or less it is uniform. Okay, it's a uniform distribution, and this point is somewhere in the middle. So it is not an outlier from the point of view of, what's this? Feature 1. Oh, sorry. The point of view of feature 1. So it's not an outlier from the point of view of feature 1. What about this one? So if we collapse it, we can see that again, the distribution is something more or less uniform, and this outlier actually is this anomaly is actually not an outlier from the point of view of feature 2. So if you study these cases feature by feature, this anomalous case does not have any outlier in its profile. Okay? So by searching, by hunting outliers, you cannot find anomalies necessarily. There are some anomalies that they don't have any outlier in their features, but the combination, okay, that's very important. The combination of features are anomalous. It is not every single feature, but the combination of them together is anomalous. So these were two examples. More tangible examples if you want.